Last time we looked at the exacting area of excavating ancient wrecks. This time we're going to look at the equally challenging area of finding ancient wrecks in the first place. My name is Mike Haig, and I'm the project director of a brand new venture in the Caribbean called Wreck Hunters, looking to teach the skills and techniques of diving archaeology in the crystal clear waters of the Caribbean of a small island called Utila, in almost perfect diving conditions, focused on the remains of an 18th century wreck we call the Oliver. And as a precursor to that, I'm running a series of sessions covering topics that diving archaeologists deal with all the time. And in this one, we're going to be looking at how we find ancient wrecks in the first place. In truth, ancient wrecks are found in one of two ways. Either by accident, which in my experience is the most common method. A fisherman loses his nets on a protruding timber. A spear fisherman sees a strange shape on the seabed, which turns out to be the anchor of a doomed vessel. The alternative method is by research and systematic searching. And it is that method that I'll be talking about in this session. The searchers for wrecks face three main problems. The first of which is getting the location of the lost vessel. There is a list of wrecks that found in the New World from 1492 to 1520. They include such useful references as the Santiago de Palo Capitano, sunk in St. Anne's Bay in Jamaica. Hardly a precise location. The second problem are the charts of the time. These are not the precise hydrographic masterpieces we have today. Many cartographers, in fact, copied other people's work, so the opportunities for omissions and inaccuracies are large. And the third problem is the depth of the site. Many sites are beyond the operational limits of divers, and therefore we need to use what we call electronic methods. Some sites, of course, are shallow, and here you can use more basic methods focused on divers with less expensive equipment. There has been a tendency, some might say an obsession, in recent years to look for deep wrecks, both in terms of archaeology and what we also might call prestige shipwrecks. The theory is sound. Wrecks located at depth are less prone to becoming smashed up and deteriorated. Therefore, their contents, either in knowledge, in terms of preservation, and perhaps in terms of value, are better than those that founder in shallow waters that are open to a great deal of degradation. However, of the 3 to 4 million shipwrecks known in the world, many are in the shallows. Surely these require some attention. When undertaking a search, the first point is you need to record carefully the area covered. If you do not do so, your search will have been a waste of time. You'll either end up covering the same area twice, or you may miss parts of the seabed in which your target may lie. Before putting together a search plan, three things need to be considered. The first one is the type of object you're looking for. Is your wreck site dispersed, or is the wreck fairly intact as far as you can tell? Secondly, what knowledge do you have about the wrecking? Is there some tradition, some oral or written records of how the wreck came about and where she foundered? And the third factor is knowledge of the local area. And for us, this means the seabed. Is it rocky? Is it sandy? What type of material is it? And from these three factors, we put together a search plan. And this search plan will tell you what area to cover, what width to search, and of course also how long your search is likely to take. It's normally quicker to find a large target in a small area than a small target in a large area. The first area we'll talk about are visual searches. These are normally focused on divers using low-cost equipment in relatively shallow depths and in reasonable visibility. Most divers are aware of swimline, grid, and circular searches from their training. In the past, to speed things up, divers were towed behind underwater sledges. The Oliver was found by such a method. One of the original members, Gunter Gordowski, tells the story of how he and his buddy were being towed behind an inflatable, looking for wrecks. He glanced over to see his buddy being followed by a 6-foot shark. A few minutes later, when Gunter looked again, the sledge was there, but neither his buddy nor the shark were. On return to the vessel, Gunter was happy to see his friend, who was totally unaware of his encounter with a wild animal. Nowadays, we use underwater scooters. When we get beyond the range of divers, or that divers can operate in safely, we then turn to towed cameras and remotely operated vehicles, or ROVs. Clearly, there's a cost implication doing this. But many of these underwater robots do excite the public imagination. Many will remember the discovery of the Titanic in 1985, with the submarine Alvin and the ROV Jason Jr. Alvin, or DSV.2 to give it its proper name, was built in 1964, owned by the US Navy and operated by the Woods Hole Oceanographic Institute. After many refurbishments, Alvin is still in use today. Who says underwater technology does not have a long life? The problem, however, is that all these visual methods tend to be limited to search areas which are quite small. So when we want to look for larger areas, we must fall back on electronic methods. The simplest electronic method is the echo sounder. Many of you will be used to using such a machine. Back in 1990, I was with a group of divers that successfully managed to relocate the wreck of the Imoko Cadiz using an echo sounder. Our approach was to look for appropriate soundings and then drop a weight and a buoy on these, then sending down divers to check what was at the bottom. After a day of bounce diving, it was felt it was not appropriate to continue, so we went to recover the buoys we had put down. As we pulled up one, there was rust all over the rope. We immediately put the shot down again, divers were dispatched, and the Imoko Cadiz was discovered. Not completely scientific, but it worked in the end. More advanced methods are magnetometers and side-scan sonar. The Mare Rose, in fact, was located by an early example of side-scan sonar. But the problem comes when your surface conditions make it difficult to use towed vehicles, or when your targets are underneath obstructions. What do you do then? The answer is to use an AUV, an autonomous underwater vehicle. This is a robot programmed by its operators, but has very little input from them during the dive. The advantage is that it has no umbilical, which means it is independent of any surface conditions that might make its operation difficult, and can go under obstructions such as ice, which ROVs cannot because of their umbilical connections to the surface. An AUV is set up with a number of electronic gadgets which help it to both navigate the sea bottom and also map the sea bottom. Before one can be launched, a CDT, a conductivity, depth and test cast, is made by sending a small probe to the seabed. From this information, the payloads on the AUV are programmed. Before launch, the sensory arrays are audited. The propulsion units are tested. The rudder and other mechanical parts are checked. The navigational system is reviewed, and in case everything goes wrong and the vehicle has to be recovered and goes into emergency mode, the GPS and satellite communication systems are also interrogated. The unit is then normally launched, backwards first, down a chute. Normally a recovery team is on hand when this happens in case of any problems. The AUV then dives beneath the waves, normally at an angle of about 20 degrees, but it can be as much as 45. The AUV dives. She goes to what's called a loiter station, where checks are taken out on the robot to make sure she's running properly. She then moves to a corner of the search area and moves to autonomous working. The navigational system is programmed so she runs in parallel lines, a little bit like mowing your lawn. Every so often, she returns to predetermined places where a rendezvous, handshake as it's called, is carried out to make sure she's running properly. Now it's important to understand we're not dealing in real time here, and neither can the support vessel see what's going on the seabed. We have to wait for the AUV to come back for that. In order to find wrecks, the AUV is fitted with side scan sonar. The problem is that the way it's set up on an AUV is it can create blind spots. So directly under the AUV, there are other sensors which scan the seabed to make sure a full picture is returned. The vessel, the AUV, finishes its task and returns to the vessel. In the search, the key is altitude. If the AUV is flown too high, it will cover a large area, but the images you get might not be the quality that you need. If she's flown too low, it'll take a long time to cover the area, therefore adding to cost. It costs a fortune to keep these vessels in the operational mode, and nobody has an unlimited budget. So after all that time and cost, there are no guarantees, which is probably why most wrecks are still found by accident. Having looked at the various methods of locating wrecks, next time we're going to look at the area of conservation. And until then, I wish you all safe and enjoyable diving.